And then what did you do after that? And what, okay, so you put them both under the same house then? So you said it was 3.1 to the 12th over 3.1 to the 4, and you got 3.1 to the 8? That's what you did? Okay, and then square root is the same thing as raising something to the 1/2 power. So what's 8 divided by 2? Say it. Okay, so this is what Maddie did, which is pretty genius. Did most people do it that way? No. Most people did it this way. Most people said 3.1, if they did it. That's a good point. 3.1 raised to the 12th over 3.1 raised to the 4th. If they have the same radicand, they can live under the same radical. Like this was an apartment and an apartment, so we put both the apartments in the same building. That is allowed because they have the same radicand. If it was a square root and a cube root, this next step that Maddie did would not be allowed. Do you have to do that step? No. Most people last period instead did, what's 12 divided by 2? 6. What's 4 divided by 2? 2. So they did this. They simplified the square root of 3.1 raised to the 12th. They got 3.1 raised to the 6th. They simplified square root of 3.1 raised to the 4th. They got 3.1 raised to the 2. Then they subtracted, and they still ended up at 3.1 raised to the 4. So the genius is Maddie and Brown. Most of us are the green. Doesn't matter as long as you ended up with that kind of answer. And followed some rules of exponents. Now, if Aaron was being really fancy, could Aaron have done 5 minus 4 is 1, 1 plus 7 is 8, 3.1 raised to 8, take the square root of that, and still end up at 3.1 raised to the 4th? Yes, she could have. There's more than one way. She could have handled this. Going deep. Okay. We are starting a new LCF lesson today. We've already handled the 1 through 14. We're now on graphing quadratic functions. We're going to work 1 and 2 together, and then 3 and 4 are going to be your problem, or at least 3. At least 3. Okay, so let's start with number 1. We're given this graph of a quadratic function. They say when h of t equals blank, the object is at ground zero, is at ground level. Good gravy. When h of t equals blank, the object is at ground level. How do you know if something's on the ground?
0.
It's at 0. It would be 0 feet. Because it's on the ground, that means it's on the grass. If you would like to, you can color that like grass. Okay, the object starts on the ground and ends on the ground. So give me those 2 time measurements. How many seconds? 0 and 8 seconds. It started at 0 seconds on the ground. It ended back on the ground at 8 seconds. Awesome. The notation H4 means blank, means at blank seconds the object is blank feet above the ground level. Good grief. H at 4. H at 4. What is 4? Is it time? Is it height? What is the 4? It's 4 seconds. Our notation is H of t. The t is seconds, so H of 4 would mean 4 seconds. So H of 4 equals blank. What is it at 4? It's 16. So if you're looking at 4 seconds, our graph reaches 16 feet in the air. So H of 4 equals 16 means at 4 seconds, the object is 16 feet above ground level. And then they thought we were stupid, so they wrote the next sentence. This is the maximum point on the graph. We kind of got that. How long is our object in the air total? 8 seconds. It ended back on the ground at 8. So it took 8 seconds for that ride. Or whatever this is. And then before we go any further, let's stop for a second. Looking at this graph of this parabola, what real life thing could make this journey? It went 16 feet in the air. It took 8 seconds total. It went that high. Any thoughts on something in real life? Clearly, no offense, but no matter how good I am at throwing my pin, I'm not going to get it 16 feet in the air, and it's definitely not going to stay like a whole total trip of 8 seconds. It's not happening. It takes less than a second. Come on. What'd you say? Football's a good idea, but golf's a good idea. I like golf. Why would golf be better than football?
Because it goes up.
They do hit a long distance, but in golf, is our goal to be as high as possible? Isn't it to go as far as possible? So he's right and yet wrong at the same time. We'd probably want more like that kind of motion, it going further, a different kind of parabola, a fatter one, not this tall, skinny one. Okay, looking at this tall, skinny one, football is not going to be a good one because of this point right here. We got to start on the ground and end on the ground. So think of something else. A bottle rocket starts on the ground and ends on the ground, and it does go high. Does it last that long, though? Nah, probably not. Anyone else got one? Last period came up with a silly one. They said a really good bouncy ball. Like this could be one of the bounces of the ball. Maybe remote controlled airplane. You could how high it would go, yes, and you can make it take that long, and it would start from the ground. That's the best one I've heard today. I'm gonna write that down. That's a good idea. Okay. Now back on track. We're on part D. It says the notation HT equals 7 means the height of the object is blank feet. Is how many feet? HT equals 7 means the height of the object is blank feet at the times blank and blank seconds. It's 7 feet at the times when was the ball, or apparently our airplane, 7 feet in the air. At 1 second, and then how many other seconds? 7 seconds. Okay, so again, they said, when did it hit 7? If we look on our graph and look down at that x-axis, it was at 7 feet at 1 second. It was at 7 feet at 7 seconds. Miss Compton, why did it pass 7 twice? Because of gravity. It went that high and then came back down. Okay, and then it says the notation H5 equals blank. So at 5, what should I put? 15. Because at 5, we go up to 15. So at 5 seconds means the object is 5 feet in the air, means the object is 15 feet in the air at 5 seconds. Is there anyone who's having any trouble with this notation today? It's still function notation, we've just not used it with quadratics. Okay, then flip over. We're about to start getting deep. Domain and range are back. Remind me, what is domain? It's the x values that our function would take. And what is range? Thank you, Maddie. Except in our graph, they're not using x's and y's. They're using t's for time and h of t's to represent the height over some given time. I should probably zoom in. That would help. Okay, so we need a domain and we need a range. So what is the domain of our function? Look at the front. Look back on the graph. What is the domain? How long did it last? So our domain is, it started at 0 seconds, and it lasted all the way until 8 seconds. You can either write it in interval notation, or you can write it with brackets. Either one is acceptable. What is our range?
Zero to
Say it
zero
again.
to 16.
That's as high as it went. It didn't go higher than 16 feet. Or we could say 0 to 16. But I'm not done answering the question, because if you read it, it says, not only does it say what are the domain and range, they say explain what the domain and range mean within the context of the situation. So what does 0 to 8 mean?
How high it went.
The 0 to 8? Yes, the domain means the object traveled in the air. I'm being super fancy today. Yours does not have to be near as fancy. The domain means the object traveled in the air for 8 seconds. It would help if you could see. And what is the range? I'm going to put the range as the height the object traveled, like Kennedy was saying. It didn't go higher. It was not Kennedy, it was Hannah. It didn't go higher than 16. Okay. Then we get real complicated. You knew it was inevitable. It says something about Stella. Stella was asked to give an example of what this graph could represent in the real world, kind of like you. She wrote this graph could represent a punt in a football game where the punter kicked the football standing on the goal line and a player caught it 80 yards away. The ball was 16 feet in the air at the highest point. Is Stella correct or incorrect with her example? Explain your reasoning. Do we like Stella's example? What is wrong with Stella's example? What do you mean it doesn't start on the ground? Okay, so our issue is that the object was supposed to start on the ground, and in football, she's right. Don't they hold it and kind of drop it so it doesn't actually start on the ground? So our first issue is in football, a punt does not start on the ground. Very good. I'm really impressed y'all came up with it last period. I might have had to borrow an object and like pretend to punt things away until they finally got through the whole punts don't start on the ground. So that's our first issue. I think we should have another issue with Stella's example. And it has to do with the axes, what they represent. Because let's read through what she said again. This graph could represent a punt in a football game where the punter kicked the football standing on the goal line and a player caught it 80 yards away. I have an issue with the 80 yards and the touching the... I thought the x-axis, so she's saying that this 8 is for 80 yards. Is that 8 for a yards?
I don't think so.
It's for seconds. So for the x-axis for us, in all the real-life examples we're going to work, the x-axis is always time. Minutes, seconds, hours, some sort of time. So our second issue has to do with that. So how to phrase that? The x-axis represents time, not distance. Okay, and then we've got to draw our own little graph. It says, draw a diagram that illustrates the actual path that her little fake football thing is going to travel. So here's my graph. Notice that we keep just using the first quadrant. We're never going anywhere near negatives because we're not traveling negative time or throwing a football negative distance. So we're always just in that first quadrant. Okay. Kennedy's right. I cannot start at the ground. I've got to start so high in the air. How tall do you think this football person is? How tall is a normal punter? Taller than, I'm 5'3", so you want to say he's about 6 feet? So how many feet high in the air is the ball when it starts? It's 6, you start at your head? Like, okay, like 4 or 5. Now the reason I was going to say 3, but you hold it kind of high, don't you? But at the same time it drops a little. So I like the 4.
I like the 3 part.
I like the 3 I can do 3 or 4. Okay, so we're just making this up. You know that. We're just making a good, like yesterday, educated guess. Educated. In football, is our goal to go really high with the punt? What is our goal with the punt?
Go really high.
Go really high? Like, really far. Our goal is to get it as close to your goal line and as far away from my goal line as possible. So our goal is to go really far. So we're wanting more of like the fat, sad face than we are the skinny one. So we're wanting something like this. And then we're going to guess 1, 2, 3, 4, 5, 6, 7, 8. I made mine happen in 8 seconds. Just because our example was happening in 8 seconds. But let's be honest, in real life, does a punt actually take 8 seconds? No, I haven't timed it, but I have a feeling it's about, I mean, does it even, do they even clock it? I know I'm sounding real stupid. I watch a lot of football. Why do I not know that?
Come on.
Do they stop the time for a punt? No, they don't, right? Is the clock going when you punt it? But it can't be taking more than 4 seconds, right?
As soon as you punch the ball, or as soon as it snaps the ball.
As soon as how long does it normally take? You've watched a lot of games.
I don't know, 5 seconds.
Is it not longer than 5? I don't know. I'm going to pay much more attention this next football season as to how long a punt takes. I promise. Come back and see me next year after football season. I will know how long an average punt takes, but I do not know that answer. Yes, sir.
It takes at least 2 to 3 seconds for him to kick the ball, but them just for the ball to go through the air, and just them catch it someplace. That's at least like 5 seconds.
I don't know, because you know there can be 10 seconds left and they'll do a kickoff and still get a playoff. So I don't know. I'll have to Google it. I don't know.
It depends on who's kicking.
It probably does depend on who's kicking it and as to how fast. It probably does. And he's right, too, because how specific are they with the timer? Do they start the timer once his foot hits the ball or once the ball drops out of his hand? Once the ball is snapped. Okay. See, oh, Lord. I don't know things. Okay, me and the girls are out because I don't know. So we're moving on. We're going on to an example maybe all of us will understand because, yeah, you just learned I'm kind of a blown when it comes to football. Number 2 tells us that there is a rocket, yay, that it's launched at an initial velocity of 224 feet per second. That is a fast rocket. The height in feet of the rocket at any given time is given by this equation. Why is number 2 harder than number 1?
They give us an equation.
They gave us an equation. What did they not give us?
That's fine. I mean,
A graph. There's no graph. We got to make our own graph. So suddenly we're going to have to do some math on our own. We've not had to do any like this where we use an equation and make our own graph. It's going to be tons of fun. Okay, so the first one says, when will the height of the rocket reach a height of 528 feet? We want to know when the rocket will be that high in the air. And then they tell us something useful in parentheses. We'll come back to it in a second. And then we see our least favorite words. Determine an appropriate equation and then solve it by factoring. Write the answer in even more favorite words, function notation, and then write an answer as a sentence in terms of the situation. Okay, so let's just one tiny step at a time. We're given an equation, HT equals 224T minus 16T squared. I need to put the 528 somewhere. Where do I put the 528? For H of t. They tell you HT is 528. So instead of putting HT, I'm going to put 528 equals 224T minus 16T squared. I cannot factor this. I don't have everybody on one side of the equation. I'm going to move everybody to the left side. Now, Ms. Compton, why would you do that? My only logic is I really don't like that guy being negative. You know I love my first term to be a positive number. So I'm going to add 16t squared to both sides. So I'll have 16t squared. I'm going to subtract 224 from both sides. So I'll have minus 224t. And then that 528 is positive. So it'll be plus 528 equals 0. Now, if I say all my words again, what I did is move the two people on the right to the left-hand side. So that one was negative, now he's positive. That one was positive, now he's negative. I'm moving them all over because now that they're all on one side, I can hopefully factor. What's the first thing we're supposed to do when we get to a factoring problem? Is there a GCF? So we need to figure out, is there a number that goes into 16, 224, and 528? 2, but we want the biggest. Is there a bigger?
4.
Does 16 go in all of them? Find out.
Yes.
16 does. So if we pull out a 16, we're left with t squared and then what? Minus 14t, and then what's the last one? 33. Perfect. So now the real question is, can we factor this function, t squared minus 14 plus 33? I need two things that add to negative 14 and multiply to positive 33. Negative 11 and negative 3 give you negative 14. Negative 11 and negative 3 give you positive 33. It is negative 11 and negative 3. So it's t minus 11 and t minus 3. And I am out of room, but that all equals 0. Okay. So Ms. Compton's pulled in some voodoo magic. She took the equation given. She rearranged it so everybody was on one side. She factored. And now somehow she's supposed to get answers from her factoring. How do we do that? We set each of the terms equal to 0 because our equation is equal to 0. Well, it's silly to write 16 equals 0 because 16 doesn't equal 0. So we're poor 16. He's not doing anything but making us skinnier. He's not doing anything. But we can set the other two equal to 0. We need to set t minus 11 equal to 0. And we need to set t minus 3 equal to 0. What do you get when you set t minus 11 equal to 0? What do you get when you set t minus 3 equal to 0? What was t again? Remind me, because I've lost sight of what we were doing. What's t? in our problem. What is t? Time, but be specific.
Seconds.
Seconds. So something happened at 3 seconds, something happened at 11 seconds. What were we trying to figure out again?
Okay.
We were trying to figure out when our rocket was 528 feet. So at 3 seconds, our rocket is at 528 feet. And at 11 seconds, our rocket is at 528 feet. And I'm out of room, so I can't write a sentence even though it said to. The rocket reaches a height of 528 feet at 3 seconds and again at 11 seconds. So rocket, 528 feet at 3 seconds and 11 seconds. Okay, so let's say it all again. We were given an equation. We plugged in 528, and now solving that equation, we figured out that our rocket actually hit that mark of 528 feet at 3 seconds and 11 seconds. And now I'm a cheater, so I'm going to go down to the bottom, and I'm going to go ahead and graph those 2 points. So I know at 3 seconds, my graph should be, my rocket was at 528 feet. That's a little closer to the 5 than it is the 6. I also know that at 11 seconds, mine was at 528 feet, so it's a little closer to the 5 than to the 6. Is there anyone who's epically lost at this point? I agree, there's a lot of work required to get 2 points on our graph. Okay, those 2 points, they are zeros.
No.
How do you find zeros? What are zeros?
Start and finish.
Okay, and that's where the graph is crossing the... Yeah, so since those points aren't crossing the x-axis, those are not our roots. Those are, again, just where our rocket is at 528 feet. If you want to draw that in to help your brain, I understand. Okay, so we go back to B, and we pray life gets easier. It says, when will the rocket reach the ground? How do we know if something's on the ground?
It's up left. It's at 0.
It's at 0. So no wonder they tell us to plug in 0. So our equation was h of t equals 224t minus 16t squared. But they tell us to plug in 0 because we want to know what the time is when our object is on the ground. But again, I'm unhappy with that negative. I don't know how to factor. We've not been factoring. Let me rephrase that. We've not been factoring with the negative with the squared guy. So I'm going to multiply both sides by -1, and I'll have 0 equals, and I'm going to rearrange at the same time because we're that good today, 16t squared minus 224t. I swapped those two, and I changed everybody's sign. So now the question is, can we factor 16t squared minus 224t? What can we pull out of both terms? We can pull out a 16 and what else? Yeah. You can pull out a 16t. What would be left if we pulled out a 16t? I heard you, and then what else? It wouldn't be minus 224, would it? Minus 14, because 224 divided by 16 is 14. And again, I'm going to do that same idea of I'm going to set each of these terms equal to 0. So I'll say 0 equals 16t, and 0 equals t minus 14. So I get 14 equals t for this one. And I get 0 for this one because 0 divided by 16 is 0. I'm happy with this. Why am I happy? I'm especially happy with the 0 answer. Why am I happy with that? It started at 0 on the ground. That makes me feel good about myself. How long did this rocket fly? 14 seconds. We know when it started and when it ended. So if I had room, which I do a little bit, I would say h at 0 equals 0 and h at 0 equals 14. And then you and I both know this means the rocket reaches the ground at 14 seconds. Okay. So we got that. Well, again, I'm a cheater. I'm going to go down to that graph. I know I need to put a point at 0, 0. And I also need to put a point at 14, 0, 14. Because it comes back to the ground after 14 seconds. And then, thank God, part C does not say anything about plugging anything in, although it says, when will the rocket reach its maximum height? Determine the answer using the parabola symmetry and its roots. Show the work that leads to your answer. We're going to cheat, and we're not even going to show any work, because you're just that smart. Where should the axis of symmetry be? What would be the middle of this? It would be at 7 because it's 14 total, so 7 would be in the middle. So we know x equals 7, and it's not actually x equals 7, is it? It's t equals 7, is our axis of symmetry. It also helps you to see my words. Okay, and while that's lovely, when will the rocket reach its maximum height? At 7 seconds. So if you want to go add words, you can. The rocket will reach its max height at 7 seconds because that's its axis of symmetry. See, that one was way easier. Yay, parabolas for being symmetric. And then they dared to ask the question, what is the max height of the rocket? So they want us to put a point. They want a 7 something or other. They need a point so we can actually connect the dots and make a pretty parabola. So we need to calculate the max height of the rocket. So here's our equation again. Do I just replace h of t with 7? Remind me what 7 is again? 7 seconds. Where in this equation do you see seconds? What's standing in for the seconds?
T.
The t's. So let's replace all the t's with 7s. And then someone will get out their fancy calculator and calculate this for me.
Um, 1568.
1568, and then what?
Minus 784.
Minus 784, and what does that equal?
Um, 7.
So our max height happens at 784 feet. So at 7, I need to go up to 784, so a little closer to the 8 than the 7. And I can finally connect my dots as best I can. I did better on the left hand side this time. It's funny, 'cause last period I did better on the left hand side. How funny. The good news is we've been cheating all along. So we've done part E. We've been using our answers to draw this graph this whole time. And then we get to part F and it says, what are the domain and the range of this graph? So I need to know the domain and the range of this graph. So what is the domain? It is, so 0 less than or equal to t less than or equal to 14. Agree. Or you can do 0, 14. Hey, Anna, do y'all use interval notation or do you use the brackets more? I'm betting the brackets. I thought so. Okay, and then the range. How high did it go? So I should put 0 less than or equal to h of t is less than or equal to 784. Or you can say 0 to 784. Is there anyone who is just completely cannot, they just don't know what happened? You knew we were going to make the quadratics useful somehow in real life. I talked a lot, and you did a very good job, and you participated really well. So you don't have to do number 4. You only have to do number 3 by Monday. That is my consolation prize to you. And when I say do number 3, like Ashanti tries, he tries real hard.